Hello, my name is José Manuel Sánchez Guardado. I am a master student of the Universidad de Guanajuato, and today I will present the work named Photoluminescence property of erbium-doped metal oxide matrix by down conversion process from the first to the third biological window. The main objective of this work is to create a new materials capable of presenting an alternative to classical medical imaging techniques, as well as the so-called non-invasive but high-energy techniques, using the Allet-Tier biological window, which is above 1500 nanometers in the near-infrared, and that has been less studied than the second window, making possible to separate the excitation and luminescence wavelengths in a simple way. Currently, there are multiple materials used in medical imaging, mainly based on precious metals nanoparticles such as gold and silver, which, despite their good response, presents high cost as well as complicated synthesis techniques. An alternative used for this purpose is in telecommunication is matrix doping with lanthanide elements with well-defined absorption and emission levels within semiconductor matrices. Finally, it has been observed that the combination of metal oxides has been presented as a good receptor for the lanthanide elements by sharing characteristics of ionic radio and electronegativities, which also have high chemical stability, which enables that their use as a low toxicity biological marker. The synthesis was made by a modified Pecini method, a one-to-one aqueous solution of water ethanol in which a 2 to 1 molar ratio of citric acid and the corresponding metal nitrate, iron, bismuth, and aluminium were added, followed by erbium nitrate for a concentration of 1% molar. After evaporating the ethanol, 1 milliliter of ethylene glycol and 5 milliliters of ammonium hydroxide were added to form a solid gel at 170 Celsius degree. The gel obtained was burned in a preheat muffle at 600 Celsius degree by 5 minutes, obtaining a low-density sponge, and after being crushed, calcined at different temperatures to obtain the optimal phase for each material. In the diffractograms, we can see that for the aluminum oxide, an hexagonal phase was obtained with a small crystal size associated with the tightness of peaks. On the other hand, the bismuth oxide and iron oxide samples present a high purity and crystallinity in the monoclinic and rhombohedral phase respectively, with low symmetry which help to produce a better luminescent response, where the presence of the erbium ion does not significantly modify the crystalline structure. In the absorption spectrum, we can see the presence of the erbium ion directly in the bismuth and aluminum oxide. Due to peaks of 918 and 1550 nanometers, the absorption of 808 nanometers in the oxide matrix being also very visible of bismuth. For its part, iron oxide is the sample with the least evidence of the presence of the ion, possibly hidden under the absorption of the same matrix, but with a slight presence in the 1550 nanometers area. The erbium-doped aluminum oxide shows a good photoluminescent response at 1550 nanometers when it's excited with 808 nanometers by the transition 4E30 half to 4E50 half. For its part, the doped iron oxide sample has a lower luminescent response associated with the low absorption of the ion in the region of 808 nanometers. In the same way, the sample with the highest photoluminescent response at 1550 nanometers is the bismuth oxide doped with 1% of erbium, which also presents an emission centered at 1250 nanometers, typical of the matrix. We obtained three matrices of metallic oxides by an easy synthesis method with a relatively good emission within the third biological window, highlighting aluminum oxide and bismuth oxide with a good response at 1550 nanometers when it's excited with 808 nanometers, corresponding to the two energy levels of erbium. At the same time, it can be observed that bismuth oxide presents an emission band typical of the matrix within the second biological window, so this material is presented as an even more practical option for medical imaging, allowing the flexibility of the detector used. Finally, for the development of these works, the study of cytotoxicity of the materials in cell culture is sought for the subsequent use within the some living behinds and the appropriate functionalization.